Welcome back to Performance Process, the podcast where we break down the processes behind the world's best performances so that you can apply them to your own riding. This is the next episode in our Aero Testing at Home series. A couple of weeks ago, we spoke to Xavier Disley of Aero Coach to sort of kick off this series. And today, we're back with a deep dive into AeroSensor, a drag measurement system from the company of the same name. We speak to Barnaby Garood, the former F1 aerodynamicist and founder of AeroSensor, and Barnaby explains how AeroSensor works, how to use it, the things to consider when using an AeroSensor to aero test at home. We cover everything from device setup to course selection, from yaw angle to body position tracking and velodrome testing. We discuss the challenges, innovations and opportunities that AeroSensor brings to both pros and amateurs looking to gain those elusive aero gains. So, by and large, what you have here is a deep dive into AeroSensor and a bit of a breakdown on what these aero drag measurement systems can offer us when we're testing at home. As already explained, we're going to be taking a bit of a deep dive into the various aero testing options that are available to us. So without further ado, let's kick off this episode delving into AeroSensor. Barnaby Garood, welcome to the podcast. Thank you for your time today. You're with AeroSensor, one of the few commercially available AeroSensors currently on the market. I've already made this podcast confusing because your company is called AeroSensor and I'm referring to all the AeroSensors as AeroSensors, but we'll try to work through that as best we can and make it as decipherable as we can. Welcome to the show.
Thank you very much. Thanks for having me on, Ronan.
Your AeroSensor has been around, I feel like it's been around forever because I think I first wrote about it, what was it, like August 2022, so well over 2 years ago at this point. And it's now been on the market. You had like a crowd fundraiser campaign that was successful, got it to market. It's been on the market for about a year now. For those who aren't aware of it though, what is AeroSensor? Give us an introduction to the brand and the device.
Okay, perfect. So AeroSensor is a device that measures your aerodynamic drag on the bike. In the real world, it's based on my own experience in Formula One, where part of my job was going to the track and measuring aerodynamic forces on the car at the track. And I used to do this. I came up with this algorithm for measuring the drag of the car and thought maybe 6 or 7 years ago now, it would be great if you could do it on the bike. Started working on it with a guy called John Buckley, as you know. We kind of ended up going in slightly different directions. Ultimately, it's something that gives you your aerodynamic drag. It's like having, I tell people to think of it like a wind tunnel for your bike on the road. So we have the main device is called AeroSensor that measures your drag. It links to your power meter and wheel speed sensor and takes its own measurement of basically wind speed and wind yaw angle and elevation. And it uses all that information to calculate your drag, which it sends to the Garmin. We've also got two other devices that have sort of grown alongside this. And it's taken me about 6 years to develop it overall. And whilst you're going, you have these ideas, and being an engineer, I always want to develop new stuff. So we've got Aero Body, which measures the rider body position. And then we've also got Aerodrome that is for the track and gives you sort of very accurate lap timing. So you basically get more accurate aerodynamic drag data.
The AeroSensor is the part that we all look towards. That's effectively a wind sensor pitot tube device that's mounted on the front of the bike.
Yeah, exactly. So one thing I've used to find in F1 that the traditional pitot tube style, what we call yaw pitos. So they look, if people know what a pitot tube that you might see sticking out the front of an aeroplane, the yaw pitot has 3 holes in the tip, and they use that to measure both the wind speed and the angle of the flow approaching the front of the car or bike. But in F1, we used to find that in very low speed, high yaw angle corners like hairpins, it would just give nonsense results. So going into this, we thought, well, on a bike, it doesn't take much wind to see quite high yaw angles. You're not going very fast, certainly not in the context of Formula One. So we need to come up with something different. So the very first thing we did was come up with a now patented probe design that gives us very accurate wind speed and wind yaw angle up to over 45 degrees yaw. That's
kind of a key differentiator here, in that there have been aero devices previously that couldn't account for yaw, and as such, while they may have been useful in some scenarios, they maybe weren't so useful outdoors and those sorts of conditions you've just described. But that's kind of what you're trying to tackle head on, that your AeroSensor can open up aero testing in those environments. Is that correct?
Yeah, exactly. I've always been sort of right from the outset knowing the importance of we always wanted to account for that, because there's two aspects to it. There's actually knowing what the wind yaw is doing, and then there's also making sure you've got the right measurement of wind speed when there is some wind yaw. And actually, since developing it, when we go out testing, you'll see that even if it doesn't feel like there's much wind, you'll easily see quite a lot of wind yaw angles, because a little bit of wind going past trees and houses and other objects on the road means that the wind's moving around all the time. One thing, as an example, if we see an average of 10 degrees wind yaw angle, we'll see it actually blowing around between plus 30 and minus 10. So it's moving around all the time. And I think we're so used to riding in that sort of atmosphere or that sort of environment, you don't really notice it until you see the data. So whilst a lot of people will say, oh, you never really see yaw angles much above 10 degrees, actually you always see wind yaw angles well above 10 degrees, but just for short durations of time. If you want an accurate measurement, you've got to make sure that all the time your measurement is solid. So you need to be able to capture those higher yaw angles to get a good overall measurement.
That's definitely something I'm guilty of saying, is that realistically you don't see these high yaw angles in like time trial scenarios, and that's so interesting that you're saying that your device is showing us data that actually you do.
Yeah, I'd say that, like, as part of our analysis, we display like a histogram of how much time you spend at different wind yaw angles. So you break it down in, say, 1 degree buckets, and say, you're spending X% of your time at each wind yaw angle. And now that we have quite a lot of customers, I have a lot of people sending me data just to check that they're doing the right thing. And it's actually very rare that you'll see 0 time above 10 degrees, unless it's an extremely calm day. And actually, more often than not, you'll see people with, short period gusts that go up over 20 degrees. But it'll only be for a fraction of a second, but happening quite often. So I think if you want to get a good average over that period, you've got to be able to kind of capture that information, because it gives you a better number overall. It allows you to understand how calm the conditions that you're riding in are, and then also gives you some context to your data, because we've certainly seen before that with some, say, bike helmets, some are great at 0 yaw, like on the velodrome, but as soon as you get a bit of gust, or even we've seen as soon as the rider starts moving their head around, they can rapidly lose a lot of performance. So it's important to know what's going on.
And that kind of gets us into the Aero body, because that's actually a device for checking that the rider is maintaining and helping the rider maintain position from test to test and run to run. Is that right?
Yeah, exactly. So in fact, John and I started by developing that 4 or 5 years ago, actually just for our own testing, because neither of us are professional athletes. And when we're doing our own testing, we needed to make sure that it wasn't our body position moving around that was affecting the drag. And actually, we've soon realized that this is a good product in its own right. So it's basically got 2 infrared lasers, one points at your head, one at your chest. And it just gives you a simple distance measurement. It goes on your handlebars, so it measures basically the height of your head and the height of your chest. So although it's not capturing all of your body position by any stretch, probably to the first order, the biggest effect on your drag is your head height. If you drop your head, most of the time you're going to lose drag. If you lift it up, you're going to gain drag. So trying to understand how consistently you're able to hold a position, and then training to hold your best position is really important. So as an example, I've done this quite a few times, done testing with people, and you get them set up on a turbo trainer, you set up Aero body. I say, get into riding position. We take a sort of a datum, so the device shows you your delta to that datum, and it will change color on the Garmin, or even beep at you if you're outside of that, outside of some tolerance of that. And almost always, people can't actually ride in the position they think they're riding in when you just sit them on a turbo trainer. So that goes back to the wind tunnel, which is what people think of as the gold standard. Like, quite often you get people in the wind tunnel who are getting into a position that they can't possibly ride in, because they don't have to look forward, they don't have to put out a reasonable power. So being able to measure that with pretty good accuracy, and we're accurate to about 2 millimeters. It means that you can really track what your body's doing. And we found with even professional cyclists, say at the velodrome, they'll almost always drift up as they get tired. And that obviously has a huge effect on the data.
Yeah, I can imagine. Finally, you've got Aerodrome. What's that device doing?
So Aerodrome is just a little box with some electronics in it, and it connects to what's called a tape switch. So it's like a pressure sensitive switch that you lay across the track. And when you go over that with your wheel, it sends a trigger to the Garmin, well, actually a trigger to the Aero sensor that's accurate to about a millisecond. So it means each time you go over that it's basically re-zeros your position on track. So we know where the corners are, which allows us to take account of cornering effects. But then it also gives you your drag coefficient every lap, both to the Garmin, but also to a trackside computer. So if you've got a coach there, they can see in real time every lap what your drag's doing. So quite often when I've been doing tests with other people, like after a couple of laps, you'll say, look, this isn't working out. This helmet's clearly worse. Come in, let's change it, go out again. Interestingly, the biggest limitation I've found to track testing is just the rider's legs. They always get tired and have to give up. So making sure that you're only spending time making yourself faster is pretty critical.
Yeah, I can imagine the benefit of just knowing much quicker that, call this test off because this isn't an upgrade, this is a downgrade.
Yeah, exactly. And then the other thing is because you're able to re-zero at exactly the same point on track, it removes any amount of error coming from the elevation. It allows us, if you can put a track map into the device so that we know where you are on the say in the corners. So that allows us to take account of cornering forces, lean angle, all that sort of stuff that just allows us to make those refinements to the accuracy of the system.
The devices are available separately. I think AeroSensor is £730. The complete package is around about £1,400. I know there's a sale on at the moment, so I'm not exactly precise in those prices. Apologies, Barney. But what's the benefit of using AeroSensor versus free aero testing like a Chung method or something like that?
The Chung method is fine and it works really well, and that's really the father of aerodynamic testing. What it doesn't take account of is wind. So if you're testing outdoors and there's any level of wind, you're going to start seeing a degradation in forces. Plus, it's slow. Typically, you need to kind of take your fit file data, go home, put it into Golden Cheetah or similar software. And then what the idea of the Chung method is that you're playing around with, say, your rolling resistance, various other factors, the elevation profile, to try and get everything to line up. By using AeroSensor, we're automatically accounted for the wind, which of course is the biggest effect on your aerodynamic drag. But also we're measuring elevation, and so you're getting that data straight away in real time. So if you're going out on the road to do your own testing, typically we talk about out and back testing for on the road. When you're out there, you can see what's going on. So if you're playing around with your body position or going through helmets, you can just sit at the side of the road and do that. So there's a guy called Ronnie Kuba, for example, who uses this as part of his coaching and bike fitting process. So he takes people out to a stretch of road and does out and back testing with his system. And he also kind of posts videos on it. I think it's on YouTube and Instagram.
I've watched some of the videos. He's using it. Is he using a road or a bike path? It looks either way. His videos are well worth tuning into.
Exactly. And of course, he spent a lot of time learning how to get the best out of the system. But I think the point is, if you put the effort into it, you can get some really great results, and results that are, to put it into context, we can get easily within about 1.5% repeatability. The wind tunnel, last time I was there, they were saying that they'd normally expect around 1%. So it's, considering you can pay for a system that you own and you can do almost wind tunnel quality testing at a time of your choosing, is extremely powerful.
There's also a question, or at least there is always a question for me, as to, is it a pro or a con that it's more representative testing in the real world versus testing in the wind tunnel? Maybe an impossible one to answer, but I'm going to throw it at you anyway. I should probably caveat that you're probably slightly biased.
Yeah, no, of course. Personally, with my background in motorsport, people have been talking, ever since I've been working for 20 years, that, for example, the CFD using computers to figure out the airflow are going to replace the wind tunnel. And the reality is that they've always been complementary technologies. And I think it's the same with on-road testing. There are certain things that you can do more easily, and it is more representative. As you say, you're in a representative position, you've got representative wind. However, if you want to do, say, for sprint cyclists, for example, where you need to do a lot of testing at high speed, it's just not possible on a bike because no one's got legs to do it. And I know some national federations have looked at putting electric motors on their bikes or pushing people along with motorbikes and then leaving them for an hour, but it's really not practical. So for something like skin suit testing for sprint athletes, you've got to have the wind tunnel. However, I think for most people, for like time trialists, triathletes, that sort of thing, I would recommend doing most of your tests on the road because that's realistic conditions. We used to say races aren't won in the wind tunnel, and that's, I think, never more true than on bikes because you can end up with not only with slightly wrong results because you're not in realistic wind conditions, but unusable results because you can't actually ride in the position that you found in the wind tunnel. So it's ultimately, I think a bit of both is necessary, but I'd certainly advocate testing in the real world where you can.
Who's this for then? Is it you've mentioned some potential use cases there, but is there a level you need to be at to consider before you can consider investing in an aero testing device?
I don't think so. I would say that anybody who wants to go fast on their bike, whether it's from somebody trying to beat their times on Strava through to Olympic athletes or pro tour cyclists, everybody can gain something from this. And actually, I would almost say that if you're an amateur cyclist, the amount of low-hanging fruit, when I see, I live in the Surrey Hills, you get a huge amount of cyclists going around on a Sunday with extremely expensive bikes. You see these, £10,000 plus on a bike and their position is just terrible. So you're like, well, you're going to get so much faster if you just learn how to ride in a decent position. Like in terms of value for money, it's just a no-brainer.
Do you think, I'm full of impossible questions here today, but 10 years from now, is it those riders who are fixing their aero positions, or is that something you think bike fitters the bigger market here?
I don't know, it's a tough one. I sort of tend to think of it a bit like power meters were 20 years ago. They were seen as pretty niche. I can remember people saying that, knowing what my power is doesn't help me. I know I need to find more power. Like, why would I need that? Whereas now pro cyclists won't cycle without it. I don't think we'll ever get to people never wanting to cycle without it, but I think it will become mainstream. Our target initially was always to start off by looking at the bike fitters, the pro cyclists, the national federations, etc., and then hope that it trickles down from there. But I think there is a world where in 10 years' time, it will be as prominent as power meters on bikes, because if you want to make yourself faster, it is by far the quickest and cheapest way to improve your speed on the bike.
I think it was Michael Hutchinson who said that power meters are like tattoos. They look great when you're young, but the older you get, the worse they start to look. And actually, Aero says, as things begin getting a bit looser, the tattoo doesn't look quite as good as it used to. I think was the idea he had. But maybe actually Aero sensors are the opposite on that. To a certain extent, you can, and I know you've had like Masters R record attempts in that, where the definition of Masters, they're older athletes, but they're getting more and more aerodynamic all the time. And so perhaps it's the opposite of a power meter. These are things that, regardless of the years marching on, they can get better and better looking.
Yeah, exactly. I've got customers who are, I think, in their 70s, actually using this thing to do their masters records. So, like, very, very much so. And I think with these things, in fact, I was still talking to somebody last week who was saying that they saw somebody who was maybe a few stone overweight riding a very fancy bike, and maybe they should concentrate their efforts elsewhere. But which is a kind of funny take on it. But actually, they're still going to benefit from having a lighter bike. They're still going to benefit from being more aerodynamic. So I think people who say, and many people have said this to me, like, I'm a brick, why would I bother trying to measure my aero? It's like, well, because you've got the most to gain, like, easily. If you get your head down more, if you get yourself into more aero position, proportionally, you can have a much bigger impact on your aerodynamic drag. And because aerodynamic drag is basically around 80% on the flat of your overall power output, if you reduce that by 10-20%, which some of these people could easily do, it's almost 10-20% of saving in power.
It's a big ask to try and gain that in power. You're always going to be better trying to save it. On that note, just you've briefly touched on some of the reaction you get. What is the reaction been to AeroSensor? It's in the market now a year. I kind of always assume that the people who are interested in these things, you don't need to convert them. They're already converted. You're preaching to the choir. What's the reaction been like with the rest of the cycling community?
Yeah, so I think it's been good. Honestly, it's been not as good as I had anticipated. I think anybody who founds a company to develop a device is probably going to overestimate the popularity of it. With those, as you say, with our Indiegogo, our crowdfunding campaign, and then the first few months of trading, we sold an awful lot because people already believe in it. They're excited to see something new come out. There's this concept they call, I think, crossing the chasm, where you're basically trying to get from these early adopters through to the mass market. I think we're somewhere in there at the moment. So it's picking up, and that's, I think, it's like a tipping point thing. The more people that use it, and the more they see other people, especially professionals, using it, the more people will take it seriously. And actually, there's, as you'll know, Ronan, there are other people that are shortly going to be coming out with devices. And we've done a little bit of work even with Body Rocket recently, because they're using AeroSensor for the wind speed measurement part of their device at the moment. And I think that can only be good for us, because the more people that are in the market, the more seriously people are going to take it. And the more they'll realize that this isn't snake oil that we're selling people, then they're not sham devices. They're real things that can make you faster. So generally, it's been good. You do get, people on the comments on forums saying that they're, and what one guy said, it's sitting out in front of the bike. How on earth can it measure the drag when you're measuring the air in front of the drop bike? You've got other people who say it's going to be far too much. They're a little bit scared of it. How can I possibly use something that's measuring my aerodynamics? It's going to be far too complicated. And that's for sure is always a challenge. It's never going to be as easy as a speed sensor or a power meter. But little by little, I feel like we're starting to kind of break down those barriers and slowly reach the masses. But it's going to be a long journey, I think, before you see it really in the mainstream.
Yeah, I always tell the story of the former teammate of mine who, when we first got power meters back, I think this was like 2006, and the coach had instructed him to do a ride and stay below 200 watts. It was like an endurance ride or something, and a recovery ride, perhaps, I can't remember. But I think he had like gone over 200 watts, and so he pedaled backwards to try and bring it down or undo the... Yeah, it's funny now looking back, but at the time, it just, I always think it's an indication like how far we've come in terms of understanding power. And everybody uses power now, and perhaps we go the same way with aero testing.
Yeah, no, I think so. And it was, and actually earlier I was just kind of looking at a couple of things, and one of which was the hour record, which I think is always an interesting one. And just in the last 10 years, gone up from 51k to 56.8 with Gano last year, and that clearly a lot of that is technology driven and primarily aerodynamic. So it's sort of pretty interesting or exciting times we're living in, because aerodynamics is moving forward at pace. You look at what bikes are like now compared to 10 or 20 years ago, it's where the focus is. And so that can only trickle down to the user actually figuring out that, if your bike's a little bit more aerodynamic, well, it's only 20% of your overall drag. How about, looking at the big lump on top of it?
Amazing thing about the hour record for me is that what was a world record 10 years ago is now what masters and national record attempts are targeting and beating on a regular basis. And that, like, Jens Voigt's hour record literally 10 years ago is now surpassed by considerable number of other riders who were not Jens Voigt level, world tour level pros.
Wow. No, I didn't fully appreciate that bit.
And I think that is, there are other advances in terms of training and understanding the effect of heat in that, but I think it is largely down to improved aerodynamics and understanding of aerodynamics.
Yeah, no, exactly. Because this is the other thing, the power output aerodynamically is about the speed cubed. So to go up by a little bit actually costs a lot of power. And so that increase over 10 years, I worked out, was about 35% extra power. And it's not 35%, like, that's just not possible. Like it's not an extra 1% saving in drivetrain efficiency. Like, that's the majority of that is aerodynamic. And so I think people are starting to kind of wake up to that and take it more seriously.
You've briefly touched on a couple of things I want to come back to, but before we do, you mentioned pros using that. You're a partner with Lidl Trek. What's that team using the AeroSensor for? Or do you work with them? Do they just get the device and go and do their own thing? Or how does that partnership look?
They get the device and they do their own thing. So I haven't had as much interaction as we'd initially had in mind. I think this, the season gets busy and they get into it, but they're usually two main things. One is to test the aerodynamics of their riders on the road, so doing out and back testing. But then there's this other idea, and honestly, I don't know if they've done it yet, but this was very much what I've been talking to them and others about, which is kind of going out on recce's before, say, a time trial and using the device to measure the wind around the track, because that can have a huge effect on what you choose, well, both your strategy and your choice of equipment. So actually, a few years ago, we did it with one Pro Tour team who at the Tour de France went out in the morning. I think that might have been the first time you covered this, actually.
Yes.
And they measured the wind conditions around the track, and actually on one part of the track, it was that the wind yaw was much higher than what the weather data was saying. As a result, they switched tires, they switched wheels from their intended wheel and won the stage. How much of winning the stage was down to the wheels or not, you can't say, but margins are pretty small, as you say. So getting that stuff right is, makes a big difference. So I think it's interesting that there's a lot of this sort of second order effect that can come out of these devices that give people a lot of insight into how they should run their race. I think in the future, there's a possibility that people will start, like I've got this dream that people will say in Kona, anybody who rides Kona just with an AeroSensor measures that data, puts it into a database, you correlate it with the weather data, and so people can say for a race, can figure out actually what the wind conditions will be looking like, because with real world conditions, geography, buildings, trees, hedges, etc., the wind on the road does not look like the wind coming from the Met Office.
Like on that point, are you having any conversations with manufacturers about R&D work that they might be doing, or testing that manufacturers might do, or is that something you've looked at?
I've been in touch with some manufacturers, and there's one that's bought a unit and just we're kind of hands off, like we just want to use that for our own testing. There's been others who have trialed it, and we haven't got further than that at the moment. But there's definitely interest, I think, picking up. It's one of those things that, a year ago I was getting very little traction when I contact these sorts of people, but now when people say we're still here, more and more people are using it. There was a good video we did, Scientific American, with USA Triathlon during the Olympics. There's more and more of that sort of stuff coming out that's demonstrating the utility of these devices. So I think the manufacturers are starting to think about it, because people are learning that just testing things in the wind tunnel isn't really good enough anymore. Yeah,
that's a whole other topic where I'm going to get us back to discussing how the everyday rider might be using the AeroSensor. And I want to use this to sort of lay out, what does an actual test look like? I've done countless. I'm not sure if I'm doing them right or not. I made it sound very, very complicated on a podcast I did last year.
I heard it.
Is it like that, or is that just me?
That's just you, but
you can say that if you want. That's fine.
I've never seen anybody go quite to the efforts that you went to, but your data is actually some of the best data we've had, actually. Typically, testing is, I'll just sort of start from the beginning and explain how somebody would normally do a test. They'd do out and back testing, is the usual outdoor testing we do, if you want to actually measure your aerodynamics and measure an effect. So what you do is you'd find a stretch of road that's ideally quiet, or a cycle path. Quiet meaning for little traffic, ideally not too much wind. It doesn't need to be perfectly flat, but you need to be able to maintain the same speed in both directions. And again, with corners, it doesn't matter if if it's not straight, just so long as you don't need to slow down for a big corner. So somewhere between 600 meters and 1,000 meters, and you'd accelerate up to speed, hold that speed until the end of your stretch, and then brake hard. And what AeroSense does is when you hit a predefined target speed, it will automatically start your lap. It averages your drag until you brake hard. And then that gives you your CDA for that out. You turn around, do the same thing on the way back. And the reason we do the out and backs is if there's some wind, it can, although we take account of wind, it can have a small offset in your CDA. So getting the out and the back gives you a very good average. And then we normally say to people to repeat that 3 times. And the reason for 3 times is I've found that sometimes, for whatever reason, maybe a car passes you or something, you get a big gust of wind or something, you might get an outlier. And if you got 3, it makes it easier to spot an outlier than if you got 2. If you got 2 values and they're different, you don't really know what's going on. If you've got 3 values and 2 are the same and one's different, then probably the one that's different is an outlier. So that's normally how we ask people to test. Normally a test session, we'd say like start and do your first 3 out and backs and your baseline. We normally say repeat that because I haven't fully got to the bottom of it, but I think there's some power meters sort of drift a little bit at the beginning. So I don't know if it's bedding in or temperature or what, but you can see a little bit of an offset between those first 2 runs. It also gives you a chance to get your aerodynamic calibration factor, which is calculated automatically. And that just takes account of the fact that the wind slows down a little bit as it approaches you on the bike. So we need to scale up the wind speed a little bit from what the device measures. Then you go into your test, say change your helmet or your body position or whatever it may be. And then most importantly, and no one ever wants to do this, is to repeat your baseline at the end. So you go back to the starting setup and repeat that. And it's amazing how many people say, I just didn't have time to do it. But then they've got confusion about the results. And the point is, if for whatever reason there's, and you've seen this firsthand, Ronan, if there's, you're never going to get a perfect repeat. There's going to be some difference for whatever reason. If those 2 repeats are, say, within 1%, then you've got pretty good confidence that anything more than 1% away from those values is definitely worse or definitely better. If you don't do that and something else has changed, then you cannot be sure that your results are real. So we always, and it comes back from my background in wind tunnel testing, even at, when I first started, Ferrari, it's just a golden rule. You always start your session with a baseline, finish it with a baseline, so you know that what your repeatability is over the session. Without that, you can easily get very lost.
You can never have too many baselines, can you?
No, exactly. But it's extra time out there doing your riding. So as you gain more confidence with the system, you can sort of relax that a little bit. So you might not need to do 2 baselines at the beginning if those 2 baselines are always very similar. Sometimes we'd say, if you're doing a lot of changes, you'd want to do an extra baseline in the middle. You might want to relax that if once you start understanding what your repeatability is, because it's not just our device, it's your power meter, it's you, how well are you able to maintain your position, it's the wind, a lot of different factors can affect that.
I just said you can never have too many baselines. I was going to ask you, can you have too many test interventions or test configurations? But perhaps the question there is actually like, is there like a window that you can test within before you need to repeat a baseline, or what are you looking at? Because quite often, I think the problem I was running into was my expectations were too high. I was trying to test too much in one day. And while I was doing loads of baselines in between, it was just too much, I think.
Yeah, it depends on a few things. It depends on, so one thing we come up against a lot is people go out and test helmets. And they'll say, oh, these 2 helmets are giving me the same, they're within my repeatability. Like, how can I decide which one's better? The answer is you can't. There's nothing to say that they can't be essentially the same amount of performance. If they're within 0.25% of your overall drag, then you ain't ever going to see a difference. If they're within, say, 1.5%, you might just about be able to, but you need to do more repeats, more baselines. So if you're trying to resolve small differences, then the more repeats of those differences you do, the better. So we talk about sometimes A/B testing, where you'll do literally your baseline, your option, then back to your baseline, then back to your option, then back to your baseline. And if it's only just outside your repeatability, you do that repeat enough times, you'll start to see something will start to emerge that says this one's clearly better, that you might not see if you just do a baseline and your test. And that's the same with all things. One of my more recent jobs, I was working with IndyCar in the US. We were doing trying to measure extremely small variations in drag, because that's just all, the Indy 500, it's just all about straight line speed. And we'd have to do a huge number of repeats in a wind tunnel that costs $30,000 for an 8-hour day. Like, it's one of the most expensive wind tunnels in the world. That's just the nature of the beast. Aerodynamics is never an exact science.
I want to go back just to the sort of explanation you were giving of the process there. You mentioned calibration factor. Mm-hmm. Some people, when they hear the word calibration, they might start getting nervous. Can you explain just in a bit more detail what is the calibration factor? How much like math, how much calibration, how much offsetting is there to do on a test by test basis?
Yeah. Okay. So as I mentioned, physics just dictates that the wind slows down as it approaches you and the bike. And actually, we've measured this, and you need to go something like 2 meters ahead of the bike before you don't have that effect at all. So with the bike just hanging from your handlebars, like maybe 150, 200 mil in front of the stem, you're going to have a calibration factor that's somewhere between, say, 1.2 and 1.4, which is basically a scaling up of the dynamic pressure. The dynamic pressure is a function of wind speed, and that's basically the if you put your hand out of the car window, the dynamic pressure is what you're feeling on your hand. Because that wind slows down as it approaches the bike, we're measuring a slower wind speed and therefore a slower dynamic pressure, and we need to scale that back up. Now, how we figure that out is on your out and back. If you've got like a constant wind and you go out one way, let's say you've got a wind speed of 5 kilometers an hour, coming straight down the road, on the way out, you'll see a 5 kilometer an hour headwind. On the way back, you'll see a tailwind. If you average that out over the whole thing, you'll know that you should have zero headwind. And so you use that assumption to say, well, what would if I look at my average headwind using AeroSensor, what would I need to scale that up by to get zero? And that gives you your calibration factor. Now, over 3 out and backs, you normally get a pretty good value for that. So we have, you'd normally get it within, say, 1% or so. So depending on what you're testing and how windy it is, we say you go out and back, you get that value on the Garmin, you put it back into the Garmin, which actually sends it to the AeroSensor for the base calculation. The reason you need a reason, like it needs to be within 10% to get good elevation data is the bottom line. I won't go into technicalities why that is, but you can't perfectly correct for it. If it's small changes, which you normally get with small changes to your body position, then you can post correct it. So we currently have this Microsoft Excel analysis tool, and you can just put in a flag there saying, I want you to automatically apply the calibration factor. So for every run you do, it'll calculate the calibration factor and then correct your data because it was slightly different to what you had before. Now, if it's a little bit windy or you've had a few cars go past, that can move a bit, it'd be a little bit more noisy. So if you're testing, say, helmets that you know are unlikely to affect your calibration factor by much, you can say, you know what, I'm going to turn off auto calibration. I know what my calibration factor is. I've done it before. I'll stick that in there, and then you get a much more consistent CDA value. Unfortunately, it's always going to be something that's a little bit subjective because it just is what it is. If you're doing big sort of aero bar angles or big changes in body position, that value is going to change substantially. So you need to be able to measure it. If you're doing small changes or aero socks or something like that, then you can just park it. But that's basically what's required. And it will be required of any aero sensor based device, from the old Velicomp Notio people through. The advantage with our system is you can get your calibration factor at the same time as testing. And whilst other devices, some new to the market, hide that away, although some people find it a little bit intimidating, we make sure you see that every time so you have full transparency of what's going on. And if you don't want to look at it, you don't want to get into that detail, you just turn auto calibration on and you forget about it. But it's there. And actually in the calibration tool, I've got this traffic light system now. So if your calibration factor is very consistent, it'll give you a green traffic light, say your results are good. If it's not, you'll get a red traffic light to say, just be a little bit cautious of this data because it's a bit more noisy.
What I'm hearing there, or what a lot of people will be hoping you're saying, is that you can just hit auto calibration and forget about it. Is there anything you're missing out on if you go that route?
I actually think you're not missing out on much because our traffic light system will tell you to pay attention if it's a problem. It's never going to be just kind of turn it on and forget it. You always need to just check that the quality of your data is good because there's just too many environmental factors involved in aero testing to just ignore everything. Calibrations
and whatnot. Like how much extra faff, for that lack of a better term, is there before each round of testing? In terms of like, are you having to calibrate parameters between every run? Are you having to measure wheel circumferences? What else might slow down a test, or how seamless a process is it?
So before you ever go testing, you need to measure your wheel circumference. And we suggest a rollout where you just put a bit of tape on the wheel and the ground. I'd normally roll 2 wheel revolutions put a bit of tape there and measure the two. It gives you a much more accurate result than GPS. And actually recently I've discovered on somebody else's recommendation that if you don't do that weighted, so you need actually to be sitting on the bike when you roll forward. So that's about 1% error if you don't. But that gives you the most accurate data. You need to weigh yourself before every test. And also, as you were, Brennan, be careful about, if you're going to take some water with you, like keep the water bottle on your bike, because that can be a couple of kilos easily, which is going to affect things. Again, with that, if you're going up and down a hill and accelerating a lot, then you're getting your weight perfect is really important. If you're testing on a bit of flat road and you're holding a constant speed, then it's not going to make any difference. So there's a sort of variability in the importance of that. And then you mentioned the power meter. So it depends on the power meter is the bottom line. We see some power meters have quite a lot of drift. And you see that each time you calibrate it, it will move slightly. Other power meters like SRM, unsurprisingly, I find to be just rock solid. You can just park it. So normally you can sort of get a feeling as you go how consistent your power meter is, and therefore how often you need to calibrate it.
I guess this is a question again based on my own experience, but how accurate do you need to be stressed about being with those measurements? Like again, wheel circumference, the way I had ended up doing it was I was using a fine tip felt tip marker to like score over and back on the tire, and then move that point with the wet ink to like the bottom touching the ground on the top of a piece of masking tape. Then I get on the bike and roll forward. And then that marker tip again would, on a second bit of masking tape further down the floor, make the second marking. And then you measure the 2 points between the markings. But then I was like, is my tape measure 0 mil? Is it actually 0? Or is it, how accurate is my tape measure? Do you need to be concerned about how accurate your tape measure is, or is close enough good enough?
I think close enough is good enough. And in the end, your wheel circumference is about 2,000 millimeters. So, and the wheel speed is a component of your drag measurement. It's not everything. So normally what we're most concerned with is your relative measurement of drag. So we're not really concerned with getting your absolute CDA number spot on. You're wanting to see, like, is this helmet faster than that helmet? With that in mind, if you're out by 10 millimeters on your wheel circumference, it's going to make zero difference to which helmet is best. One thing I've found is that it's like a mindset. If you put effort into making everything as good as you can, then the results you get will be better. So yes, I mean, near enough is good enough. But what is near enough? For something like wheel circumference, if you're within like 1%, so which is 20 millimeters, you're never going to be able to tell the difference.
I think for me, I'll come to my own defense here, and that I was trying to conduct aero testing that I could use the results from to publish differences between products that are available on the market. And as such, to be fair to those individual products, I had to be as entirely accurate as possible. And so it wasn't really the relative or the delta, it was like the absolute that was that I needed to know. Ultimately, the testing I did, I was more than happy to use results from that for my own benefit. I wasn't ultimately happy to, make or break a product based on the results that I had. And that's why I was going to those extremes to try and be that accurate, which I don't think everybody needs to do. As you said, the relative is more important than the absolute.
Exactly. But there's a balance to be had. I think if you're very methodical about everything, and basically what you're trying to do is just remove subjectivity from it. It's like one thing we see a lot is people will put on their helmet they think is going to be faster and tuck their head down a little bit more, because there's just like a psychological, this is going to be fast, I'm going to go for it now. So trying to take out all those extra factors by being very meticulous about everything is going to always give you better results. That's for sure. But you can get results that are actionable and entirely useful by not going quite to those lengths.
I want to come back to like the test lap that you can ride on. You've mentioned out and backs as the ideal. Can the device be used on? Is there an ideal out and back? I guess is the first question.
I think the ideal about out and back, the biggest thing is low traffic. So getting rid of, if there's no cars or other bikes or anything else on there, then you are golden. Especially if the wind is low, you'll just get mega results. Being flat, because you're doing out and backs, being flat is less important, because you're always, you're going up by 5 meters one way and down by 5 meters the other way. It cancels out. If it's perfectly flat, it's a little bit better because you can just be much, much more consistent on the out and the back. Your power each way will be the same. So if there's an error in your power meter, it'll sort of cancel out. In an ideal world, flat, smooth, no traffic, no corners is the best. But and the road just outside my house here, that I normally get one or two cars coming by, and it's, I think, sort of 5 or 6 meters over the 600 meters of elevation change. I can easily get within 1.5% with sort of relatively little effort. So it doesn't need to be perfect, but if you want really good results, that's flat, smooth, no traffic.
Could you, if you so desired, use a loop instead of an out and back?
Yeah, a loop's even better. And actually, if you have a loop, you can then use Aerodrome, and that allows you to get the automatic laps, or you can just press lap on the Garmin. You can even get, there's a wireless lap trigger you can get that you can put on your aero bars or your handlebars, and you just press that each time. And why that helps is it means you can then turn off the elevation correction. So we just then ignore elevation. Obviously, on the road out here where I'm lifting myself up 6 meters each way, that's a big component of your power. So we need to remove that in the process of working out what your aerodynamic drag is. We use barometers for measuring elevation, and the resolution's about kind of 10 centimeters. Like it's pretty fine, but if there's a lot of wind, for instance, that can be a little bit more bumpy. So again, it averages out, but it's an extra source of error that you could remove with a loop.
And then final question on this same sort of topic from myself. Could you just simply mount the AeroSensor to your bike for every training ride and do your normal training with an Aero reading on your Garmin?
Yeah, and it's that was the initial goal. What we have is we have a display that shows your average CDA over the last 30 seconds, and you can certainly, if you move around, you can see that moving in the right direction. To try and get the sort of accuracy that we're talking about, in the single-digit percents of helmets and things, it's normally not useful, because over 30 seconds is quite a short averaging period. And 30 seconds, to put it in context, that's how long they would average your drag for in the wind tunnel, which is kind of technically perfect conditions. Out on the road where your power is not constant and you've got traffic passing you and a bit of wind, it doesn't tend to give you great results. If you average over laps, so you press your lap trigger, you're coming up to a bit of straight road, so you know what, I'm just going to press my lap here, get the average for the next lap, then it's definitely a good comparison from one day to the next, how consistent you're able to maintain your drag. The other thing it's useful for is actually knowing what the wind's doing. So like a lot of people come back and say, I had a headwind all the way around. It's like, pretty sure you didn't, but now you can see how much time did you spend drafting other people? How good were you at drafting other people? Because you can see that in the amount of tailwind you've got. So it's definitely useful data. And I'd say sort of actionable. Like if you're saying like, why wasn't I certainly felt like I had it in my legs. Why wasn't I able to beat my Strava record? Maybe almost certainly it's the wind, right? So you can have a look at what the wind difference was to the last time you did it. So I think that sort of thing people are going to learn to love, because it just gives you consistency in your training numbers. And the one thing that's really missing, people now measure their power, their speed. It's the wind that's the biggest sort of differentiator between how fast you went today versus how fast you went yesterday.
Yeah, there's potentially a coaching angle to it that I hadn't considered previously. If you're working with young riders or something and you have them in a group and seeing which ones can draft the best, or yeah. I want to move us on to the sort of, you've done your testing. What's the post-test analysis? Look like you mentioned it's on an Excel sheet. Is that right?
Yeah. So when we launched, we wanted to get something out there that was kind of simple to use and most people had access to. And so we produced this Excel spreadsheet that you read your fit file into, and it does all of your calculations and basically just gives you a summary. And that's grown over the last year or so since we launched. Interestingly, it's something that I thought, and it sort of comes back to the interesting thing about releasing this kind of almost minimum viable product. You start off with I think this is good enough. I'd like to develop something more complex for the post-analysis of data, but we'll start with an Excel tool. Actually, people love the Excel tool, bizarrely. Not many people ask for an online platform. We are working on the online platform, to be clear, but the Excel tool has been pretty useful. We're also compatible with AeroTune, so that's a website that it's got its own sort of algorithm for calculating drag, and actually a really interesting array of sort of metabolic analysis tools on there as well. You can also look at your data in WKO, Golden Cheetah, even to Garmin Connect will list your CDA for each lap. The idea of this sort of specific testing is if you want to kind of go in and say, oh, actually my weight was wrong or my wheel circumference was wrong, in the Excel tool, you can post correct that and AeroTune. Actually, you can change that value and then recalculate your data. You don't need to kind of redo the testing. So at the moment, there's Excel tools, so you need to kind of manually offload your fit files. What we're hoping to release in next month is something that's going to pull your fit files down from the cloud straight into the Excel tool. So we're almost there with that. One of those things that's far more complicated than you think. And then eventually have a sort of online platform to so on any device you can see your data eventually live is the goal. But there's a unbelievable amount of work involved in that. So actually, it's been pretty interesting to see what people actually want before going into that process, because there's the old adage that people don't even know what they want before they start using it.
Yeah, anything like myself, they still don't know what they want even after they've used it. There is a page though on the Connect IQ app that is on the Garmin, and sort of that Connect IQ app sort of runs the whole testing system, testing process as you're out in the field testing. You can view everything there. That gives you a lap by lap CDA. Could you just say you've got 10 helmets, you do your 10 tests with 10 different helmets, just look through the Connect IQ app page and see, test number 5 was the fastest, that was the POC helmet or the Giro helmet or whatever I was using, test number 5. And you never actually need an Excel sheet or...
Absolutely. So it lists your calibration factor and your CDA for each lap and a few other things like your head and chest position. If you've got aero body, and then it allows you to select which laps are valid. So if you're doing out and backs, you'll normally have like a lap on your out, another lap for the turnaround, a lap for the back. So you need to turn off your turnarounds. It averages them into a summary for the run. And then each time you start and stop recording to a fit file, it'll save in a list each run CDA. So yeah, you can absolutely just do it to the side of the road. And that's what most people do. They'll go out with the test a load of things and just see it live. The advantage of, most people are going to want to kind of come home and put that into their analysis tool. So you've kind of got it properly written down. And also just what you can't see on the Excel tool is like how variable is the wind. Whereas when you come back, I can give you a histogram that says, this is the range of wind yaw angles you're getting. So that's sort of worth checking. But I think most people are just checking out different helmets or different wheels or different body positions or whatever it is, taking this to on the app.
It's the app also sort of gives you on that same page like an X for that was a good test or that was an invalid test. Is that?
No, you do that yourself. So as you go down, you can see the calibration and the CDA, and you might say, that calibration factor looks a bit off, and all 9 times out of 10 it'll be because like a truck passed you as you're going out. So you can turn off that out and back pair.
I thought the app gives like an indication of whether a run everything was valid or not, or.
No, it does to some extent, but it's pretty crude. So it's really just looking at sort of pretty basic things like wind speed and lap time and power, just to make sure that they're all within the same sort of ballpark. It won't try and kind of guess whether a truck passed you, for example.
It's been in the field a year now. Individuals have been using this around the world. Is there any trends you're seeing emerging from the sort of, you presumably don't get a view of the data that's being collected, but is there anything that you can say now after it's been used for a year by the general public? Any insight you've got from all that testing from so many different people?
I know it's difficult to say. Like, there's a lot of people I just never hear from. People only tend to get in touch with me when something goes wrong. So you tend to get a pretty kind of negative view of people's experience. But actually, having recently, we've got a Discord forum, actually inspired by this Gate Collective one, because I think that works really well. And so people just kind of post on that. And so you see, recently we asked people for some sort of testimonials, and we got some really great feedback in terms of people doing some testing and then winning events based on the testing they've done. There's one guy who's probably cut from a similar cloth to you, Ronan, a Japanese guy called Koki, who 3D printed his own sort of lumps and bumps to go under his sleeves. But anyway, he tested all them, found something that was faster and won a 100k PT last year. I want to say he's a kind of more maybe in his 50s. So there's people are definitely putting it to good use. It's not uncommon for people to take a little time to get going, just build confidence with the system. But once they get going, they seem to be pretty happy from as far as I can tell. So in terms of particular insights, I think the biggest thing is out and back testing is the only way to go. If you're doing actual testing, just sticking it on the bike and going on your normal rides, you're not really going to be able to test different components.
Is it, you mentioned you're working on like an online platform. Is there anything else in the works that you can tell us about? Anything that's not too top secret?
No, I think that's it. Like our big push at the moment is to get an online system, because I think that the weakest part of the whole system is the analysis tool. So like where we want to get, like, as you say, on the Connect IQ app at the moment, you can see the kind of raw data, but being able to do the stop at the side of the road, get your phone out, see that data as it was, check the quality of the data before making your decisions, I think it's going to be a real step change in functionality. So it's all very much about ease of use. On the other side, there's things like, I'd like to do a speed sensor. I'd like to be able to read multiple power meters. So, for example, we've had in the run-up to Olympics, we had a few people, especially Paralympics, asking to do tandems, for example, to read two power meters. So there's a few things like that, which are actually just a software issue. So that's something we can do. In terms of hardware, I'm pretty happy with where we are, to be honest. Nice thing about these devices is you can make a lot of improvements just in software. So once you bought the device, we just keep pushing updates. So if I think about where we were a year ago, like it's come on leaps and bounds, and still plenty to do.
Those are two things that we've had discussions about previously. Is like there was some question marks over the parameters I was using, and we had talked about a dual recording, which might help actually evaluate the parameters more so than help the aero testing. And the other thing was just a speed sensor, because some of them are not quite accurate as you would hope, more accurate than GPS, as you mentioned earlier. And obviously speed is an important component of the calculations that are happening here. But I'm you mentioned there a couple of updates, and I know there have been some significant ones recently. I'm on a newsletter there, and you can now like chop and change the data fields within the Connect IQ app, and there's a few other significant changes. Is there any major ones I'm forgetting there? I know there have been. I know you're sort of constantly updating the app and the offering.
Yeah, I think the main, and there's a lot of stuff that isn't immediately obvious to the user. Like one issue we have, for example, is because we're starting and stopping laps by acceleration. If somebody's wheel speed sensor misses a revolution, it can look like you brake very hard and accelerated back up again, which can randomly insert an extra lap. So there's sort of interestingly, getting the device out amongst this many users, you soon find all your corner cases. So there's a lot of that sort of thing going on. But then we tried to do a lot of stuff like user definable layouts on the Connect IQ app. One thing that I'm looking to do quite soon, for example, is being able to calibrate the power meter from within the app and then save the value. So each time you calibrate a power meter, it sends back a value, and every manufacturer has got a different interpretation of what that value means. But if the calibration changes, the value changes. So if we can save that to your fit file, I think that'll be really powerful, because then you can track like how much is the calibration, my fit file, my power meter moving around. So a lot of it's just going to be about that sort of thing where you're, just improving user experience, making it easier, more straightforward, fewer button clicks to do things.
Have you any advice for users on, like, some parameters they do auto offsets or auto calibration, as it's often called? Should that be switched on or switched off?
Personally, I don't like it. The thing about power meters, it's really, really hard to, without getting off the bike and doing a dynamic calibration, which I haven't ever figured out really how to do properly. You're never going to know if it's right or wrong. And it's easy for me to blame, it must be the power meter if there's a change in your repeatability. If your power meter is auto-calibrating it, it's guessing that there's no power going through it and uses this. So I think when you stop pedaling, sometimes some of the power meters will do a calibration based on that. But if you're, say your feet are still resting on the pedal, so there's still some force going through them, they're not rotating, but there is force going through them. Like, are they really that good at taking that out? It's guessing when you stop pedaling. What happens if you start pedaling during a calibration run? Like there's a lot of things I just don't like about that whole thing. I get why they do it, because it takes away a lot from the, that's required from the user. But I think the biggest thing is you don't know when it's doing it. So it could randomly be changing the offset in your data without you even knowing about it. And that,
I guess the thing though is, if the atmospherics are changing throughout your test. That will affect the power reading coming from the power meter. And so there's an argument that you do need to offset them. What I was doing was like doing a manual offset myself off the bike between each run. Is that going to aid confidence or accuracy? Which isn't a big ask, really, like to do an offset 2-second job.
Yeah, it is. Unfortunately, at the moment, you need to kind of come out of the app, find your sensor, go into it, go to calibration, click out calibrate, takes 20 seconds to do it, all the way back out again, back into the app. It's a bit of a palaver, so that's why I want to be able to do it from the app. It's just a time saver. But I think my experience has been that if you do a manual calibration before every run, you get more consistent data.
I think the other way you can do it is just with most of these power meters nowadays have a companion app or a mobile app that you can do on the phone, and you can keep your AeroSensor app running at the same time.
I didn't. Sort of stupid. I hadn't thought of that.
I'm saying most of them. I'm not sure they all have that function. They probably all do, but I know like a credit where it's due as well. Like I've used multiple different power meters with the AeroSensor and the AeroSensor app, and the one that we've most often not had an issue with was Quark or SRAM. I haven't had an SRM crank to like, as you said, I'm pretty sure they'd be pretty decent also. But yeah, the multiple different Quark parameters I've tried have worked pretty well for me.
Yeah, no, and that's certainly been my experience. And the thing is, it's very difficult to quantify. I mean, I know, I did some testing in the early days with some parameter pedals, and the results were very random. I would obviously say it's the parameter pedals. I can't prove it. One thing I can say is that as I did some tests, we have a tie-up with Belgian cycling, and I did a test with them once, and they had SRM parameters. It was the first time I'd used SRM parameters, and the repeatability in the velodrome just blew my mind. It was just suddenly everything just lines up. So to sort of anecdotally, it does make a difference.
Having thought about bike fitters running an aero testing service, is there something also like those riders in that Belgian Cycling Federation test in the Belgium would also be extremely good cyclists? Is there something also in the rider and on the bike and the way they conduct the test and deliver power and ride run to run and repeatability that is beyond like what a power meter and an aero testing device are ever going to be able to account for? Will the rider make a difference?
100%. So we did for that Tom Compton testing that we did recently with the disc on the bike. That was done by Charlie Tanfield, who was.
Did we explain what the Tom Compton test is? Sorry.
So the Tom Compton test we used to we're in the process of using it to evaluate the accuracy of our system. So what we've done is we put a sort of horizontal beam on the handlebars with two little rods going forwards, and then we run the bike just with that setup, and then we put discs of different sizes. So starting from 30 millimeter size aluminium discs, one on each side, going up to 80 millimeter size discs. And my initial thought was, let's do that in the wind tunnel and the track on the velodrome. This comes from a guy called Tom Compton, who sort of lays this down as a challenge to people who think they can measure aerodynamic drag. The
idea is you can accurately measure what the drag difference should be from introducing a different size disc. Yeah.
Exactly. So the just kind of briefly on the CDA is your CD is the coefficient of drag, A is the area, CD for a disc is a known value. I think it's about 1. I can't remember, maybe it's 1.15. And that's just true. That's just a fact. And then the area because you know the size of the disc. So if you put that on the bike, you know what it should be, and then if you measure that difference. If you agree with that difference, then you know that you're on something. Now, a 30 millimeter disc on Charlie is just less than 1% of his overall drag. And we put exactly the same bike, same rider in the wind tunnel, same bike, same rider at the velodrome. And we showed actually that we were a little bit better than the wind tunnel. There wasn't much in it, but we generally aligned a little bit better than they did, which was actually better than I had expected. So we did that test with Charlie, and he is just bulletproof. His position is, and his machine, like he's like identical power every lap, great, same speed, same position. He's like just brilliant. So yes, it is much easier to get good data. I think the biggest thing is his just body position is just locked in. So that gives you much more consistent data. So to your point, like with the SRM parameters, we had done other testing with other riders, with other professional riders, but with different parameters. And so that's where that was coming from. But yeah, so some of these pro riders, especially the track guys on TT bars, like they're pretty awesome.
Yeah, well, I guess that's not surprising to hear that the pros are very good at riding bikes, and very consistent at riding bikes also. Every time we talk, I get re-infused about doing some more aero testing. Unfortunately, I'm injured at the moment, and it's literally one of the first weeks this year where we could have actually done some aero testing here. So that's just been a bit of a double whammy. But I think it's a good place for us to wrap it up. I'm hopefully going to get doing some more aero testing pretty soon. Have you got anybody that you're aero testing with this weekend? Not expecting you to name names, or any future testing you're looking forward to?
Yeah, I'm actually going up to, I've got a couple of things that I'm doing. There's somebody interested in doing sprint testing, and we did some sprint testing the other week actually that turned out like on one lap we were getting pretty good repeatability. So I'm off up to Manchester with a guy called Pete Mitchell who runs Blackline Coaching to start a bit of a program on that. So yeah, that's going to be quite exciting.
Well, it's kind of the opposite of, I'm thinking your Belgian riders are probably team pursuiters or something, and they're locked into a fixed position and very steady delivery of power. Sprinting seems like the complete opposite. So is there hope to be taken there for anybody listening to this podcast that regardless of how good you are riding a bike, you can go out and do some aero testing?
Yeah, exactly. As we were saying earlier, I think the people who have the most to gain are actually the people who've done the least aero testing so far, like the pro cyclists, like the Charlie Tanfields of this world. It's pretty hard to make them faster because they've spent their whole career in it. Whereas if you're a weekend warrior and you've not done no testing before, you can probably save yourself a good amount of power by getting in a better position. So actually, I think it's them that have the most to gain. But yeah, it's a hopefully will appeal to a lot of people, different people, and make a lot of people faster.
Making a lot of people faster. I think that's a good place to wrap it up. Thank you for your time today.
Awesome. Thank you so much, Brendan. It's been a pleasure.